transport layer, very, very important layer as a part of communication, that is transport layer. Transport layer. Okay, so if you understood, if you remember, so the services provided by transport layer, services, multiplexing and demultiplexing, very, very important point. So multiplexing and demultiplexing. Demultiplexing, that is the job of the office boy. Remember the job of office boy. Office boy collect the letters, distribute the letter. Multiplexing is collecting the letter, distributing the letter is demultiplexing. Okay, so another important service, if you remember, so process to process communication. What a process to process communication? So because I have already told you there are three types of communications. One is a process to process communication, one is the end to end or host to host communication, another one is hop to hop communication. Let me just reiterate that particular one, because very, very important that concept was. Okay, so if this is my source host, this is my destination host, this is my router. Okay, and so now this is connected through this. Now I am running one process P1 here, running one more process P2 here, running one process P3 here, running one process P4 here. Let's say, so whenever we have already told about the concept, so always communication happens between one process to another process. Okay, so communication happens between one process to another process. Let's say P1 process wants to send a message to P4 process. So that means, so in order to do so, what we are telling, this is a process to process communication. That means P1 process will send, P4 process will receive, and vice versa. P4 process will send back and the P1 process will receive. So this is a process to process communication. Process to process communication. And who does that? That is the responsibility of transport layer. Process to process communication. Okay, this is the responsibility of the transport layer. And as a part of it, we have already understood, if I want to send the packet from P1 process to P4 process, first of all, I have to make sure my packet is going from the source machine to the host machine. From my source machine to the destination machine, my communication should be possible. Then only I could able to deliver the packet from P1 to P4. So this is called as host to host or end to end. Host to host or end to end. End to end communication. And who provides this service? This is transport layer application. And this is possible with the help of data link layer. Jami, data link layer. Getting my point?
Yes, sir.
Okay, so data link layer provide hop to hop, network layer provide host to host or end to end, so transport layer provide process to process communication. This is the, ये picture आपका दिमाग पे fit होना चाहिए, fit हो जाना चाहिए. There should not be any exception on top of this picture. Okay, so now, so process to process communication is another important aspect as far as transport layer is concerned. So let me ask you one more question. So in order to support this process to process communication, so what is the most important information transport layer? So port number information present as extra information in the transport layer is going to facilitate the process to process communication. That means each and every process is identified by a unique information. So that is called as a port number. Port number is a unique information which is identifying a particular process as far as the communication is concerned. So that's why, so this is the basic service we have to understood. Sorry, what a transport layer provides. Okay, now let's look into what are the types of protocols that is present in transport layer. That we already know, but let me elaborate it. So types of protocols. Types of protocols. So we have already understood, so there are two types of protocols as far as transport layer is concerned, and the first one is called as UDP and another protocol is called as TCP. Everybody knows that. Okay, as far as UDP is concerned, let's try to understand some of the features of UDP. Okay, we have already understood a bit. So as far as the feature of UDP is concerned, first of all, everybody knows, so UDP is connectionless. UDP is connectionless. Whereas if I think of TCP, TCP is connection oriented. Connection oriented. What I mean to say by connection oriented and connectionless, we have already understood the concept. If I want to communicate any, if I want to transfer any data by using TCP, first of all, a connection need to be established between the client and the server. Once the connection is established, then only my data communication can happen on top of that. That means, so before establishing a connection, I cannot able to do any data transfer as far as TCP is concerned. So, but if I look into UDP, so before making any data communication, I need not to establish a connection. That's why it is called as connectionless. Okay, there is no connection to be established. So as far as the communication is in UDP is concerned, but as far as the communication in TCP is concerned, first of all, we have to establish a connection. After that connection is established, then only you can make the data communication. That's the basic difference as far as UDP and TCP is concerned. Okay, but okay, it provides reliable service, because reliability and security are two different aspects. Reliability means, so sending one data and receiving another, making ensuring that, so whatever I'm sending, the other end must receive it. That is reliability. But security means, so somebody, so nobody can, no outsider can go and see my data or take my data. So that kind of, so mechanism, if I have applied, that is a security. Okay, so now connection oriented service provide reliability service to me. But if I look into connectionless, so it is not reliable. As there is no connection, if you are sending a data in UDP, there is no guarantee. Remember this concept, there is no guarantee. आपका data जा सकता है, loss भी हो सकता है. So you do not bother about it. If you are supposed to use UDP, that means as it is connectionless, there is no guarantee that your data is going to receive at the other end. So in that case, data loss is going to happen. But in case of TCP, it is always so ensuring that if you are sending some data, means it has to receive at the other end. That is what is the main advantage of TCP over UDP. Now you can ask me the question, sir, our TCP connection oriented, it is reliable, so UDP connectionless, so why should I use UDP then? अगर ये रिलायबल नहीं है, मेरे पास एक रिलायबल सर्विस है, so why should I go on? As it is connectionless, it is fast. That means every time you want to make some data communication in TCP, so first of all you have to establish a connection. So it requires some time. Okay, so that's why, so as far as UDP is concerned, it is fast in communication, but as far as so TCP is concerned, it is reliable in communication. That is the most important advantage of both the so protocol. Now the question is, so let's look into another feature of UDP, very important feature of TCP and UDP. So UDP is called as packet oriented. UDP provide packet oriented service. Try to understand this concept, very, very important concept. So TCP provide so stream oriented or byte oriented service. Byte oriented service. What does it mean? Let's try to understand. Okay, so what is a packet oriented service? Packet oriented service means, let's say if process P1 sends 4 packets. Okay, so whatever data he's sending to P4, let's say he's so sending in terms of 4 packets. So whenever the receiver is going to receive, so he is going to receive exactly 4 packets. If this is, so this type of service is called as a packet oriented service. Whatever number of packets the sender is sending, so exactly the same number of packets the receiver is going to receive. Okay, so that means, so data in whatever number of packets the sender is sending, so data is also going to receive at the receiver end, so as same packet, same number of packets. So that is called as packet oriented service, and that what UDP follows. But if I look into TCP, let's say if the sender is sending 4 packets, there is no guarantee, so that is, so P4 is going to receive 4 packets, it may receive 3 packets. What I mean to say, so you can say, sir अभी बोल रहे थे आप TCP so reliable, अभी बोल रहे हैं 4 पैकेट ही भेजेगा, वो 3 पैकेट so receive करेगा, कैसे हो सकता है? So try to understand what I'm saying. So whatever data I'm sending, so the same data is going to receive at P4, but that data is sent so in terms of 4 packets at the sender end, but the same data is going to receive at so 3 packets in so the receiving end, or it may happen, it may be received as 5 packets at the receiving end. That means while you send 1 packet, remember this concept, while you send a packet, as far as TCP is concerned, so while sending, that packet may be divided into multiple packets, Or if you are sending multiple packets, so they may be combined and send as one packet. Okay, as far as TCP is concerned, there is no guarantee that so you will send a packet means it will receive as a packet. It may be combined with other packets and receive. It may be divided into number of sub packets or chota packet, and that also is going to receive at the receiving end. So that is why so TCP is not a packet oriented, rather it is called as a stream oriented. That means so whenever I'm receiving in the TCP, it is a stream of bytes. I can't say it is a one packet. So it is a stream of bytes, or that's why it is called as also byte oriented. That concept, first of all, you understood as far as the difference between UDP and TCP is concerned. So that is TCP is stream or byte oriented. So UDP is packet oriented. Okay, that is the two another so important features of these two protocols we should understood. Okay, now so coming to another important advantage so of UDP, we have already talked about UDP is fast. Another important advantage, if you think of, so as far as because we have already understood, we have already understood. So as far as so transport layer is concerned, every transport layer protocol is going to add its own header. Okay, let's try to understood as far as UDP is concerned. In case of UDP, so there are 8 bytes of extra information as a part of header. Okay, 8 bytes of extra information is going to be added as a part of UDP. Similarly, if I think of TCP, in case of TCP, so it is going to add minimum 20 bytes, and that can go and vary up to 60 bytes. That means in case of UDP, so the amount of header information varies from minimum 20 bytes to maximum 60 bytes. Okay, now so if this is the case, can from this perspective, can anybody think of so what is the advantage of UDP over TCP? Less overhead. Less overhead. That means amount of information going to be exchanged on top of the computer network is less. So less overhead on the network. Okay. So on the computer network which is carrying your data, so there is a less overhead in UDP as compared to TCP, because amount of data for the same data, same amount of data send करने के लिए, so in case of UDP, less amount of so information has to be passed, whereas in case of TCP, more amount of information has to be passed for sending the same data. So that's why overhead on the network is more in case of TCP than UDP. That is also another advantage of UDP over TCP as far as so I mean there are two so important advantages we talked about as far as UDP is concerned. So as a part of advantage, we can think of the first one is fast. UDP is faster as compared to TCP, and it is so encountering a less overhead. There is a less overhead as far as data communication in the network format. What is there in the segment of a UDP? Okay, first of all, we have to understood. So a segment means it is nothing but header of UDP plus the data that is coming from the application layer, or more technically we call it as a payload. Okay, so that means UDP segment is nothing but it is the header of UDP plus the data that is generated by the application layer or the payload. So that is called as a payload as far as the UDP segment is concerned. That means UDP segment contains two parts: header, UDP header plus the payload. Okay, so now let's look into payload is the data generated by application layer. So we don't have to bother about it. We have to bother about what is there in the header. Let's look into that. What is there in the UDP header? Let's look into that in detail. Okay, so now as I have already told, UDP header is nothing but it is 8 bytes. 8 bytes. 8 bytes means 64 bits. What is there in the 64 bits? Let's look into. So first of all, try to understood every row is arranged in such a way that it is going to contain 32 bits of information. 32 bits of information means 0 to 31. Okay, that is 32 bit. Okay, so now so first information UDP store is called as the source port. Source port number. And how much? So bits it consumes 16 bits. Okay, then comes the destination port number. Dest port number. So again, how much information? So it stored the information in 16 bits. Okay, so next comes, so that is the total length. Total length, that is in 16 bits. So then comes the checksum. That is also 16-bit. That means every field, every information that is stored inside the UDP is of 16-bit information. And what is those information? The first information is the source port. So then next information, demultiplex the packet to the correct process. Multiplex the packet to the correct process. Correct process. So now the question is, if destination port number is the information, so which demultiplex the packet to the correct process, then what's the usability of the source port? Who is the sender? He must know. Sure. So that's why source port number information is being sent to identify from which source this information has come. Everybody understood from which process this information has come? Everybody understood what is the source port number usability? Source port number is being used for so providing the information to the receiver, that is from which source, so from which source process this particular packet or message has been received at my end. That's also very, very important. Why? Because if that receiving endpoint wants to send back something, मान के चलिए, so I'm calling you now, you want to call me because my number is not with you, so you want to call me back. So if you store my number after receiving my number, then you can call me back. Similarly, so whenever sender is sending something, receiver is receiving something. So if the receiver wants to send back some data, he has to know what is the source port number who has sent me the data. So that's why it is very, very important to pass this information. What is the source port number? Everybody understood source port number and destination port number. Okay, and next another point. So it is 16-bit. If it is 16-bit, which is 16-bit, what is the highest number I can represent? What is the number is of 16-bit? What is the highest source port number I can assign to the power 16 minus 1? And that is nothing but 65,535. इसलिए तो बोला था ना, range of port number is from 0 to 65,535. That means total there are 65,536 ports available. And why it is? Because source port number and destination port number is stored or represented in 16-bit. Okay, and now you have already told this concept. So out of these 65,536 ports, so first 1024 ports, that is starting from 0 to 1023 port numbers. So these are called as the well-known port numbers. We have already talked about this. These are called as the well-known port numbers. So why I am calling it as a well-known port numbers? Because these are the port numbers which is used by well-known services. Okay, like for example, so as far as HTTP protocol is concerned, that is the HTTP server runs on the port number 80. If I look into the DNS server, so DNS server runs on the port number 53. If I look into the email or SMTP server runs on the port number 25. So these are the well-known ports, and this always comes within the range of 0 to 1023. So that's why first 1024 ports are reserved, and these are called as the well-known ports. So whenever you are carrying out your own task, so it is always better to go and assign a port number beyond 1023, so that no confusion is maximum time is going to arise as far as the communication is concerned. 16-bit. Total length means what? So the length of the segment. Total length means the length of the segment. Length of segment. Okay. So if the length of the segment is represented in 16-bit, can anybody, maximum length of the segment can be 65,535. But in what? अरे इसका unit क्या है? Bytes. That is very, very important to. That means maximum length of a segment can be 65,535 bytes. That means in one UDP segment, okay, or in one UDP segment, we can go and send maximum to maximum 65,535 bytes of information. That is what is the meaning of it. Okay. So now, if you understood this, next question: what is the maximum payload size in UDP? That is, I have already know what is the maximum length of the segment. That is 65,535. Okay. And segment is nothing but a combination of header and payload. So मुझे ये पूरा का पूरा size पता है. That is the segment size. So this is the segment size. Okay. Now I want to find out what is the payload size. क्या करना पड़ेगा? Just subtract the header size. Very simple. Okay. And the header size is always fixed. That is 8 bytes. So minus 8. That is coming to be 65,527 bytes. Are you getting my point or not? That means maximum payload size that is possible can be 65,527. Actually, when you go ahead, again we are going to talk about, it is not even 65,527. It is something different, but for the time being, you understood that based on the concept, maximum possible payload size is 65,000. So first of all, I have to understood what is the purpose of it. Purpose is to detect error. Detect error. Now the question is, what is the requirement of detecting error? Think of. So whenever, I have already told in the earlier classes, so whenever a communication goes on, so from one end source to my destination, okay, and let's say they are connected via some intermediate nodes. Now when a packet is received at the router end, so can anybody remember, we have already talked about there are 4 delay introduced as far as the communication is concerned. At this intermediate node router, what is the first delay that is encountered? First delay that is encountered.
Processing delay.
Received. First of all, we are checking whether the packet is a correct packet or it is a corrupted packet. That means the correctness of the packet is being so inspected. Okay. So for whether it is a correct or corrupted. Okay. So that's why. So how it can be done? So through detection of error. That means that's why it is important to detect an error whenever I receive a packet. So whether the packet is a correct packet or corrupted packet, we have to inspect it, and that is what is done by checksum. Try to understand. So checksum field facilitate me to inspect. So whether I have received a correct packet or corrupted packet. So that's why checksum is called as a error detection mechanism. Okay, understood everybody? So now, so how to do this error detection? Let's try to understood then. Okay. So from the perspective of the sender, we have to understood this checksum from perspective of sender and receiver. Okay. Let's try to understood. So what the sender job as far as checksum is concerned? Sender job is to generate the checksum. Generate the checksum. Whenever sending a message, he has to generate the checksum. And receiver end का क्या काम है? To check the checksum or use the checksum to know whether an error is happening at its end, receiving end. Because so we have to check the error at the receiving end, not at the sending end. So sender is going to generate checksum and receiver is going to check the checksum or verify the checksum. Okay. So to know whether he has received the correct data or incorrect data. Now the next question, very important. Okay. IP is the internet protocol that runs in the network layer. But as far as this IP is concerned, there are 2 versions of IP. One is called as IPv4. So as far as this checksum is concerned, so as far as IPv4 is concerned, calculation of checksum, because so at the sender end, what you are doing? Generating the checksum or calculating the checksum. So calculation of the checksum, calculation of checksum at the sender end. Where it is calculated? At the sender end. It is optional. It is optional. You may calculate the checksum or you may ignore the checksum calculation and send the packet as well. Okay, because already we know UDP is unreliable. If it is unreliable, if I receive a corrupted packet, I don't have to bother much. So that's why. So in case of UDP, if it is IPv4 protocol, so in the network layer, so then the transport layer, so that is UDP, so may calculate the checksum or may not calculate the checksum while sending the packet. But as far as IPv6 is concerned, If I'm using IPv6 protocol for my communication, if my transport layer protocol is UDP, so it is mandatory to calculate the checksum. Try to understand this. Try to remember this concept a bit. So that is in case of IPv6, because IPv6 protocol is more secure than IPv4 protocol. That's why it makes, so as a rule, you have to calculate the checksum mandatorily. So for enhancing the performance of the network. So that's why in IPv6 protocol, calculation of checksum is mandatory, whereas in IPv4 protocol, calculation of checksum is optional. Based on this concept, let's go for the, so now what a sender does for calculating the checksum. Let's go for the steps. What is the first step? The first step is whole segment is divided into 16-bit chunks. The whole segment is divided into 16-bit chunks. That means it may happens, so that is, so it may happen that, so the checks, I mean the, I mean the data may be of 512 bytes, so maybe of 1 KB. So the whole data is going to be divided into number of chunks, and each chunk size is 16-bit. That is the first rule as far as calculating the checksum is concerned. Second rule is a very important rule. So that is, now you have to calculate the sum of all 16-bit chunks. 16-bit chunks using ones complement format. Ones complement. Okay, using ones complement addition. So we have to find out sum of all the 16-bit chunks. So have you remembered the ones complement addition? Let me tell. If you forget, just try to remind it. Okay. So let's say this is my first chunk. My first chunk is, let's say, 1100 1100. This is my first chunk. I'm representing in 8 bits for subter only, because actually it is not 8 bits, it is 16 bit. Okay. So for simplicity calculation, I'm just putting 8 bit. So for the same, okay, you so try to understand this is 16 bit. Okay. So then the second chunk is, let's try to understand the second chunk is 10 10 10 10. So we have to add it by using ones complement. So let's try to understand how it is happening. 0 0 0 0 1 1 1 1 1 0 1 1 1 0 carry 1. Carry 1 means 1 here. So 1, so then 1 1 0 1 1 1 0 carry 1. Remember, if there is a last carry, this is the last carry, last bit is a carry. When it is the last bit is a carry, if I'm using ones complement addition, I have to bring this last bit into the first one and add it. So what I got? 1 1 1 0 1 1 1 0. So this is the result of addition of these two chunks. Let's say there is another chunk. Okay. So how to add it? Let's say there is a third chunk. So after dividing the whole data, I got 3 chunks. Okay. So based on that example I am giving. Okay. So now the last chunk is 1 1 1 1 0 0 0 0. Now I add it. So 1 here, 1 here, 1 here, 0 here, 1 1 0 carry 1, carry 1 1 1 0 plus 1 1 carry 1, 1 1 0 1 carry 1. So 1 1 0 again carry 1 at the end. So when there is a carry in the last bit, I have already told you have to bring it to the front and add it. So 1 1 0 carry 1, 1 1 1 1 0 carry 1, 1 1 0 carry 1, 1 1 0 carry 1, 1, then 0 1 1 0. So this is my final sum. Are you getting my point? What I'm saying? So now I have divided the whole data into 16-bit chunks. So now I go and add all the 16-bit chunks by using ones complement. So after getting, I got some final result. Seeing this final checksum, complement the final sum. Complement the final sum. Whatever is the final result final sum come, so that I complement to get. So this is the complement of it. Okay. So I complement the final sum to get the final checksum. And whatever checksum I got right now, what I have to do? So I have to go and populate inside this checksum field. जो checksum अभी मुझे मिला है, that is a 16-bit checksum, because after addition, after complement, I got a 16-bit value. So now I have to go and put it inside this 16-bit. So then go and send it. Receiver का क्या काम था? So to verify the checksum, whether he has received so the correct data or not. So he has to verify the checksum to get the correct data. What are the steps to be followed at the receiver end? Let's try to understood that. Okay, so receiver is again going to so calculate the final sum. The way sender has calculated the final sum, receiver, after receiving the data, again divide the data, received data into 16-bit chunks. So then add all the 16-bit chunks using 1's complement, then he will get a final sum at the recipient end. Receiver now got the final sum. Receiver also receiving the checksum value, because there is a checksum field and receiver has also received this information in the checksum value. Okay, now whatever checksum value he has got received and whatever final sum he has got, now